All right, in this unit, we're going to take a look at sequences and series. So the first thing we need to do is be able to perceive and develop patterns based on things we can see, number patterns, whatever else it happens to be. So in the first case, it says Jesse is making a tower using playing cards. The top 3 rows of the tower are shown. So in order to make row 1 up at the top, it took 3 playing cards. To make row 2, we had to add 6 more playing cards. To make row 3, we had to add an extra 1, 2, 3, 4, 5, 6, 7, 8, 9 playing cards. If I continue this pattern, and you can probably already tell what the pattern is, then if I add a 4th row, I'm going to keep the pattern going. And I'm going to wind up adding 12 playing cards. If I do another row beneath that, for a 5th row, then I'm going to wind up adding 15 playing cards. Now, how many triangles were in the row? The first row just had 1 triangle up at the top. Second row had 3 triangles. The next row is going to have 5 triangles, then 7 triangles, then 9 triangles. Now we can see that there's a pattern to the numbers of both the number of cards that are required to make the next row, and there's a pattern to how many triangles will exist in each row. If I go to the second example, then what I have here is Pascal's triangle. Pascal made the triangle where what happens is every next row of the triangle is created by adding the 2 diagonals above. So 1 and 1 is 2, 1 and 2 is 3. If I keep this pattern going, then it's going to keep having 1s going along the outside, and I can add the numbers that should exist on the inside. So 1 and 3 is 4, 3 and 3 is 6, 1 and 4 is 5, 6 and 4 is 10, 1 and 5 is 6, 5 and 10 is 15, 10 and 10 is 20. Now if I add up all the digits in every row, the first one just has 1. The next row, 1 and 1 makes 2. The next row, 1, 2, and 1 makes 4. The next row, 1, 3, 3, and 1 is going to make 8. The next row, 1, 4, 6, 4, 1 makes 16. And I'm sure you can see the pattern going here. The next one is going to be 32. And the 7th row is going to be 64. We can also take this equilateral triangle, and from the center points, if I connect in between the center points, then I'm going to create another equilateral triangle that fits inside. If I connect in the center of there, it's going to make another equilateral triangle. If I keep this pattern going, the next one is going to connect the 3 center points of the smaller triangle. And then the last one is going to connect those points and then connect it inside again. What do we know about this? Well, the side length of the first original triangle was 32 centimeters. If I connect by connecting in the middle, I make another equilateral triangle, and what happened was, because I split each one of these side lengths in half, every side length on the inside here is going to be half of what the original one was, which means that those would be 16. When I split it in half again, it's going to make 8, and then 4, and then 2. When I take a look at the triangles, my original one was very simple. It just had one triangle. The next one, it looks like it has 4 triangles in there, but it actually has 5. I have 1 triangle, 2 triangles, 3 triangles, 4 triangles, and then I still have that big triangle that existed here. When I get to diagram 3, I have the big triangle, and then I have the 4 triangles that are half the size. Well, technically 1/4 the size, but the side lengths are half the size. And then I'm going to wind up with 4 new triangles that fit inside. So I have a total of 9. If this pattern keeps going, which it does, every time that I split it in the middle again, I'm just adding 4 new triangles, taking me to 13 and 17. For the last case, it says the mean daily temperature in Calgary was 8 degrees on January 1st. For the next 10 days, the daily temperature decreased by 4 degrees each day. So it started at 8 degrees, then it went down to 4 degrees, then 0 degrees, then -4, then -8. So I have 6 tables that we've created from the examples we've looked at, and every number in each of them creates a pattern. So in table A, it went 3, 6, 9, 12, 15. The next term can always be calculated by adding 3 to the previous term, which means that term 6 would be 18, and term 7 would be 21. For table B, it was 1, 3, 5, 7, and 9. To get to the next term, I can do that by adding 2 to the previous term, which means that term 6 should wind up being 11, and term 7 should be 13. And I just keep that pattern going. For table C, my numbers were 1, 2, 4, 8, 16, 32, and 64. How do I get from one term to the next? Multiply the previous term by 2. So if I keep doing that, I'm going to get 128 and then 256. For table D, the numbers were 32, 16, 8, 4, and 2. Now, how do I get from one term to the next? You might say dividing by 2, but for this unit, we always think of it as multiplying by a fraction. It's the same as we always think of it as we go add to get from one term to the next, but we could add a negative number. In this case, we're multiplying the previous term by 1/2. And we'll get into why we refer to it that way in a later lesson. So if I keep going, term 6 would be 1, term 7 would be 1/2, and then we'd obviously go to 1/4, 1/8, 1/16, so on and so forth. For table E, it went 1, 5, 9, 13, 17. How do we get to the next term? By adding 4 to the previous term. So term 6 would be 21, term 7 would be 25. Just like with our example D, for table F, we went from 8 to 4 to 0 to -4 to -8. Even though we know that we're subtracting, we actually state it as we're adding -4 to each term. So if I keep adding -4, I'm going to go to -12 and then to -16.